The prudent use of antibiotics are really possible for two main reasons and have a positive impact on reducing the probability of spreading disease and also enhancing animal health. The first reason for using an antibiotic is shortening the length of time that the animal is infected. The other is reducing the pathogen load that's contained in animal products or placed into the environment. Two very clear-cut reasons. One is to protect and enhance animal health. The other is to protect public health. And the other reason is to protect ecosystem health. Now, you've heard a lot about MRSA, or methicillin-resistant Staph aureus. There is no link to meat consumption and problems with MRSA. The CDC response to a House Committees on Agriculture in February 4th in 2008 did a study and said, thus far, there is no documented role for meat consumption or handling in MRSA transmission. In other words, they didn't find it in the meat. And we're not finding it in the milk either. These tests and these examinations are continually going on by universities and other personnel around the United States each year. And so thus far, even to this date, in 2011, we've not had any indication this is a problem. Now, we talked about those tests, those screening tests of milk. Here is a partial list of the different types of tests that can be used to screen the truckloads of milk before they're unloaded. And on the right-hand side, it talks about the different assay formats. Now, I'm not going to test you on all this, but I just want you to know that there are dozens and dozens of different types of tests for milk and meat for the detection of antibiotic residues and other things. And these are commercially available, and each processing plant chooses the ones they want to use and then do it. And again, that's required by Appendix N of the Pasteurized Milk Ordinance. These antibiotic residue tests that are available for this are performance tested by the American Organization of Analytical Chemists International. They're recommended by the National Council on Interstate Milk Shippers, and they're accepted by the Center for Veterinary Medicine, Food and Drug Administration. So they're performance tested, recommended, and accepted assays. This is a tanker truck full of milk. Some of these trucks in the United States can hold about 6,000 gallons each. And for instance, in California, we produce a little bit over 720,000 truckloads of milk a year, and every truckload is screened for the presence of antibiotics before it's unloaded. Now a little bit about dairy cattle and where we're at with them. You can see from this graph that the number of dairy cows in the United States is slowly declining. However, the production per cow is on the increase, and that's because of better genetics, better animal health, better animal welfare, better nutrition, as well as better veterinary care. And so it's very interesting to note that we are able to reach the genetic potential of these cows by good animal health and well-being, good veterinary care, and good nutrition. Let's talk about once the milk gets from the farm to the processing plant, then it's pasteurized. In other words, it's heat treated. And these are the different pasteurization temperatures in centigrade and Fahrenheit. The most common one used is the 161 degrees Fahrenheit for a minimum of 15 seconds. And this is the normal time and temperature that most of your milk is pasteurized. Now, I know there's a lot of discussion about nutrients and milk and heat treatments and those types of things. And so I'll leave it to you to look at that or give me a call and we can talk about the pros and cons of heat treatment. But this pasteurization, this heat treatment, has kept milk safe for decades and decades. There are some new technologies coming online being tested. For instance, light treatment of milk using ultraviolet light at a specific wavelength or set of wavelengths. Here's an example of a pulsed laser where we took raw milk and contaminated it with a pathogen on the left, that red colony and then the white colonies. Then we treated the milk with this laser, and on the right is that same milk 30 days later at room temperature. So this is a non-thermal killing method. It can inactivate bacteria, viruses, and fungi. And what happens is the photons target the DNA and RNA, disrupt them, and then inactivate the bacteria. There are commercially available lasers and lamps, and this is being explored extensively as a way to either bundle with pasteurization so we can extend shelf life of milk, or use as a standalone method as a non-thermal way of pasteurization of milk. So stand by and watch the literature and see how this comes along. But I'm personally really excited about this, and I think those of you who are young scientists and those in middle school, grade school, high school, these are the types of things that you'll be doing someday with new innovative technologies for food safety and food security. The other thing we have to understand is the globalization of our food supply. For instance, in this graph, we look at the U.S. consumption of beef. It's fairly stable and flat. But you can see that the rest of the world, the beef consumption is on a steady increase. And so the demand for beef and protein like that is steadily growing. The same type of curve is present for milk protein and milk around the world. China is growing exponentially in their individual consumption of milk per capita. And it's doing that because it's realized that this is an important way of getting proteins and calcium and energy into the children for growth and health reasons. Here you can see that on a scale of the number of acres used to produce meat and poultry is steadily going down. In other words, we have fewer acres available, yet we have an increasing demand for foods of all types because of our increasing population. And the way that you're going to do this is you're going to manage your way through this, you're going to innovate your way through it, new technologies, new ways of thinking, and that's why we need good young minds to grow and learn to help meet these challenges. Again, the acreage per ton of meat and milk production steadily going down, yet the demand is increasing at a far faster rate. So the global food production available, again, on a global scale, the amount of acres available to produce the food is steadily on the decline because of our increasing population. So we have to be innovative and think our way through this, manage our way through it, and then work together to meet these challenges. Food security, in other words, having enough food to feed your population, is a challenge for every country in the world, including the United States. So again, here's our customer. We need to produce a safe, wholesome glass of milk, and that's being done every day right now in the United States and North America because of a good, strong regulatory system and inspection system, as well as producers and veterinarians dedicated to animal health and well-being, public health, ecosystem health, food safety, and food defense. And so on-farm food safety is the key way to keeping our milk safe, and that's what we do. And yes, okay, Bessie, it's your turn. Show them your moves. I hope to see you again. Bye-bye.